We left off right here last time, and I want to, let's see, we did the box method on this one. I want to show you what it would look like if you decided to do the distributive property 3 times on this trinomial times a trinomial. So we have to start off with that first term and send it in to all 3 of those terms. So what do I get first? 6y to the 4th. Y squared times y squared is y to the 4th. And then next, okay, that was that one. And then next, plus 4y squared, okay. Now what? We switch to this term, and we do the same thing. So plus 9y to the 3rd, okay. Good, minus 15y squared. That would be plus 6y. Okay, now what? Okay, so we're on this one now. What do we do? Minus 3y squared. That is plus 5y minus 2. Okay. Did we do all the distributing that needed to be done? All right, now what do we do? Combine like terms. So where do we start? Yeah, the 6y to the 4th is the highest degree term, so we'll start there. Does it have any like terms? No. So 6y to the 4th. Okay? So we have the y to the 3rd term is next. We got that one there. We got another one right there. It's negative 1y to the 3rd, or just negative y to the 3rd. And I'm going to cross these off as we go. So that one's gone, that one's gone, that one's gone. Kind of helps our eye see the remaining terms. Next term, the squared term. We have a 4y squared, a negative 15y squared. But we also have this negative 3y squared. So what do we get? It's actually negative 14. So we have that positive 4 and that negative 15. You put those together and you get negative 11. And then we have this one here, that negative 3. So negative 11 and negative 3 becomes negative 14 y squared. That one's done, that one's done, that one's done. Now what? The y term, I get, so plus 11y. Okay? And then the minus 2. And this is nice because we're in standard form. The 4th degree term comes first, and then the 3rd degree, and then the 2nd degree, and then the 1st degree, and then the 0 degree term. So that's standard form. All of my like terms are combined, and I'm done. Luckily for me, I didn't have to go out on a fire drill or something like that and come back and be completely lost, not know where in the world I was. You didn't know where you were. Right. It takes forever to figure it out. And then you're not sure, and maybe you missed a term. If you miss a term on something like this, you're sunk. You'll have the wrong answer in the end. So there's this way to do it. And there's also, let me get rid of this stuff, the box method way, which is what I'm going to show you now. You don't have to erase all your things. I'm just making room to be able to use the box on this. So what kind of a box do I need? 3 by 3. It doesn't have to be enormous, it just needs to be big enough to fit all of the terms in it. There we go. Now what? Okay, so 2y squared, 3y, negative 1. Down the side, 3y squared, negative 5y, 2. Okay, so now we just multiply, right, like a Punnett square, like we did over here with the box. So we get 6y to the 4th, And watch how fast I can go here. Well, I don't want to show off or something, but it goes a lot faster. So 9y to the third, negative 3y squared, negative 10y to the third, negative 15y squared, positive 5y, 4y squared, 6y, and then negative 2. So all the terms are done. Now, if I had to stop somewhere in between and go let the dog out or something, and I stopped right here, I would still have these open spots, which means that when I come back, I know exactly where to start. I don't have to worry about maybe losing a term, because all the terms that I needed are accounted for. So now when I combine like terms, I'm going to start with that fourth degree term, 6y to the fourth, and I'm going to cross it off like this. The reason I'm doing that is because what is the next term? The third degree term, and look at where they are. They're right here. So when I combine those like terms to get my negative y to the third, those like terms will cross off like so. The next degree term is the second degree term, and look at where they are. They're all along that diagonal. So I can combine those and get my negative 14y squared, and then all of those boxes are taken care of. And then my like terms here, plus 11y, those boxes are taken care of, and then finally my minus 2. So that works if you write your terms in standard form. These were written in standard form, these were written in standard form, and that makes my like terms all happen along those diagonals. Makes it really nice to combine. So it really simplifies the problem, I think. All right, your choice on these two problems. You can either use the distributive property or you can use the box method, whichever one you like. So for that first one, what do I got to do? Oh, you want to draw a box? You don't want to distribute twice? Did anybody distribute twice? Why not? It takes longer. Yeah, it's confusing. You like drawing the arcs, though? No, you don't?
I like.
Would you rather draw the box? Okay, so we'll draw the box. What kind of box do I got to draw here? 2 by 3. Okay, well, that forces me to put the binomial here and the trinomial here. That would be nice. So then we just multiply. What do we get for the first box? Okay, next box. Yep, and the next box. Don't forget the x. And then the bottom row. Good. And the next box. Good. Positive 40. Nice. Okay, so we combine like terms. What do we get? Minus 59x plus 40. There you go. That's a pretty complicated problem. That's considered to be a fairly complicated problem to be able to do in Algebra 1. And how many of you got it right? Very good. All right, good. Okay, how about this one? Somebody had to have done distributive property on this one. No? Okay. So what kind of a box do I need? 3 by 3. I like the way the arcs look. It makes kind of a nice little pattern. But then I don't draw the arcs because I'm like, no, I'm not going to draw the arcs. And then inevitably, you know, the microwave goes off or something and I got to stop. And then I lose my spot and then I'm like, why didn't I draw the arcs? Better yet, why didn't I just draw the box? 3 by 3. What do you want to put across the top? 4m squared negative 7m 5. Did anybody put the other polynomial across the top? Okay. We'll see if we get the same answer. So then that makes me have to put m squared 2m negative 3 here. All right, so what do we get now for the first box here? Good, 4m to the fourth, and then here to the third, and then here 5m squared, and then here 8m to the third, and here m squared, good. And then 10m. All right, bottom row. Second, okay. 21m, negative 15. All right. Combined like terms, what do we have? So I have these like terms right here. This one's gone. Positive 8m to the third, negative 7m to the third leaves me with positive m to the third. So plus m to the third, and those two are gone. Minus 21m squared, and those three are gone. Plus 31m, and those two are gone. Minus 15. There's your answer. That's as complicated as it gets. Actually, I could make it more complicated. What if I gave you a 5-term polynomial times a 5-term polynomial? How would you do that? A 5 by 5 box, yeah. Now you can multiply any size polynomial times any size polynomial just using the box, and you know exactly what you have to do, okay? So it's pretty good. It's a pretty good trick. All right, one more problem here. A swimming pool. This is a diagram of a swimming pool, of course. It's 15 feet by 20 feet, and there's a deck that is x feet wide all the way around the pool. So this is kind of a typical problem that you'll see on a standardized test. They tell you the dimensions of the pool. It's 15 by 20. So what is this length right here probably? Yeah, that's 20. And that makes this length 15, right? Okay, so we got that down. And then it says there's a deck that's x feet wide all the way around the pool. Well, that means how wide is it right here? X. So from here to here, it's x feet wide. What about here? X. So that is x feet wide. What about here? X. So that right there is x feet wide. What about right here? Also x. So that's what that all means. Now you have all those dimensions on there. And they want to know to write an expression for the total area of the pool and the deck. So I want to find the area of this whole thing right here. How do I find the area of a whole thing like that?
Multiply 20x squared by 20x squared?
No. How do I, just in general, how do you find, what kind of shape is that? It's a rectangle. How do you find the area of a rectangle? Yeah, base times height or length times width, right? So that means that I got to know that total length right there and multiply it by that total length right there. Well, what is this total length? No, it's not 15x squared.
15x. 15 times 15x.
No. What was your guess? It's not 15x either. Nope. Somebody had a guess over there. Nope. How far is it here? But I also have this length right here. What if that was a 3 and that was a 3? What would the total length be?
9.
There it is. It's 9. No, not 9. If this is 3 and this is 3 and this is 15,
Oh my gosh, my brain is not working.
you got to add all of those together. Yeah, so it's 15 plus x plus x. Well, what's x plus x? X plus x is 2x. So this total length right here is 15 plus 2x. Not 17x. It's 15 plus 2x. Those are not like terms. You can't combine them. What about this total length right here? Now that you know that. 20 plus 2x. Now if I want to find the area, what do I have to do? Area is length times width, right? Well, area then is, what's the length of this thing? 20 plus 2x. What's the width? 15 plus 2x. That's the area. And what are we going to do here? Yeah, multiply it out. How do we do that? FOIL. You can set up a box on this as well, but let's FOIL this one just so that we have the extra practice, because FOILing really is the preferred way to do it. So we have 20 times 15. What's 15 times 2? So what's 15 times 20? 300. Then we have 20 times 2x, so plus 40x. Then we have 2x times 15, so plus 30x. And then we have 2x times 2x, so plus 4x squared. Good. And now we want to simplify that in standard form. A equals what? Yep. Yep. Plus 300. There you go. So that's how you come up with the answer once you get to here. But the hard part is getting to this right here, being able to write that. So you have to remember that the area formula for a rectangle, which is what we're dealing with, is length times width, or base times height. But then the length is this total length right here. So if you don't know, if you're not sure how to do it, remember what I did. I made it, let's say that's 3 feet wide, and that's 3 feet wide. So then to find the total length, you got to go 3 feet, and another 20 feet, and then another 3 feet. That means I added all those together. 20 plus x became 20 plus 2x. And the same thing happened on the width there. We wind up with 15 plus 2x. So length times width means this thing times this thing. And that's what we wrote down right there. It's a skill that you have to learn. This sort of thing comes up a lot. So on the homework, there's problems that are very similar to this. So when you get to that problem and you get kind of stuck, come back here and try to remember what it was that I said and how to set that thing up. Start with area, write down your length times your width, and then go ahead and FOIL it out or use the box.